Hi everyone, welcome to another video where we're doing actual SAT problems, and this one is question number 32 of the same test we've been doing. This is the March US 2020. Question number 32 says, so we have a bunch of data here, and they're saying if the median is 8, and they're saying R is less than 11. What is the possible value of R? So whenever there's a question on median, it's a good idea to actually order things, put things in an increasing order. So let me just write, what's the smallest number here? That's a 4. Then you have a 5, and then another 5, then an 8, and then we have an 11, and then a 13. And we don't really know where the R is. We know it's just before this 11. Right? So it can be anywhere here. Now, they're saying what is the possible value of R, given that 8 is the median. So if 8 is the median, notice we have 7 values. So there's a shortcut to finding the median. That's the n plus 1 over 2th value. So like if you have 7 terms, the median would just be 7 plus 1 over 2, which is just the 4th value. So now in this case, the 4th value here is right now the 4th value is 8. So in order for 8 to be the median, R has to be after 8. So R has to be greater than 8. And we already know R is less than 11, so the possible values are only 9 and 10. So that's pretty much it. So any of these two answers would have been correct for this question. Let's go up. We've done 31. Let's do question number 30. Okay, so they're saying we have two expressions. They are equivalent. What's the value of B plus C? So now it makes sense to, expand this thing right here, and then we can just compare the coefficients. So how about let's just do that. So if I expand x minus 3 square, I'll get an x square minus, it's always a square plus 2ab plus b square. Remember, whenever you have an a plus b whole square. So this is just going to be a negative 6x plus 9 plus c. Now we know this thing is equal to this thing. So all of the coefficients should be equal. The x square terms, as you can see, are already equal. So this is a major hint. This lets us know that b here is a negative 6. Why? Because the terms in x have to be the same if the expressions are equivalent. Now that we know b is negative 6, and we also know what c is, because we know that 9 plus c is a 10, so c must be a 1. If 9 plus c is equal to 10, c must be 1, because 9 plus 1 is 10. We have both b and c right now. Let's just add them, and we're going to get negative 5. So option number D is correct. Let's see how much time. Yeah, we do have time for more questions. Let's do question number 29. Okay, this is a very common question, and you should know this down if this is something that's new to you. So whenever you have no solutions to a linear equation, what does that mean? So in any equation, there could be 3 possibilities. There could be you try and solve something and you end up with something like x is equal to 2. This is one solution. Or you try and solve things, but the x terms cancel out and you're left with something like 2 is equal to 3. This means that there are no solutions. So when is there no solutions? When the x terms cancel out. There's the third case as well, when there's infinite solutions. In that case, in infinite ones, when there's an infinite number of solutions, the constant terms also cancel out. So in the infinite case, the x terms and the constant terms both cancel. But right now, to solve this question, we just need this thing, the fact that the x terms will cancel out. So in order for the x terms to cancel out, this k has to be a 1 over 3. Why? Because the x term on the left-hand side is a 1 over 3x, if you expand this out. And so the x term on the right is a kx. So in order for these two things to cancel out, there has to be a 1 over 3x on the right hand side as well. And so in any question like this, just make sure the x terms cancel out. So think about what value should this constant have in order for the x terms to cancel. And obviously, if it's infinite solutions, you can also check the other term out. In this case, it would have been a negative k over 3.